Greetings to Dr. Anwar. I'm Vaijawan from Advanced Computer Graphics Section 2, Group 5. This is the demo video for our Assignment 1, and the theme of our group is Video Games Character. First, I'll be explaining the AI implementation part. For our AI setup, we use the River SDK because it integrates easily with Unity, provides strong support for ground plane detection, and offers seamless setup process for mobile AI. We downloaded the Riviera Unity package from the official website and imported it into our Unity project. To enable ground plane detection, the key components we use from Riviera are the AR camera, plane finder, and ground plane stage. The AR camera handles ground detection with the plane finder as its child. The ground plane stage is used to display 3D objects on the detected surface. We use perspective projection for the 3D rendering. The ground plane stage must be assigned to the plane finder's anchor stage for correct placement of the 3D objects. Our 3D game character is Hu Tao from Genshin Impact, along with two ghost models. These models are dynamically assigned as a child of the ground plane stage when a flat surface is detected. Their visibility is controlled through the ground plane manager script, which is attached to the app manager object. Now I'll briefly explain the ground plane manager script, which controls how our 3D model is placed and reset in the AR scene. At the start of the scene, the script instantiates the model and attaches it to the ground plane stage, but keeps it hidden until a flat surface is detected. When the user taps on a detected surface, the place object function is triggered. It checks whether the tap is over a UI element like a button. If not, the model becomes visible and is placed at the tap position with the correct rotation. We also created a reset placement function to reset the model's position, rotation, and scale. This is useful if the user wants to reposition or reorient the model. Next, the script includes a check called isTouchOverUI to make sure the model isn't accidentally placed when the user interacts with the UI controls. So that's all from me. Thank you.
Hello, I'm JUNHUI. I would like to explain how we realize several advanced computer graphics techniques in Unity. Using our project as an example, we will cover translation, rotation, scaling, projection, shadows, and animation, all this driven by built-in Unity components and simple scripts. First, let's talk about translation. In our player movement script, we capture joystick input as a two-dimensional vector, normalize it to maintain consistent speed in every direction, and then multiply by a defined move speed and time.delta time. By calling transform.translate in word space, we smoothly move our character Hu Tao through the scene. At the same time, we update an animator parameter called isMoving, which triggers the appropriate walk or idle animations. Next is rotation. We detect one-finger swipe gestures in our gesture control script. Whenever the user swipes left or right, we calculate the horizontal swipe delta and call this function. This rotates Hu Tao around her vertical axis in real time. We also set the is rotating flag in the animator, giving visual feedback that reflects the rotation. And the next is scaling. Scaling comes from two-finger pinch gestures. When two touches are detected, we measure the distance between them to compute the scale factor. We climb this factor to minimum and maximum value, then apply it uniformly to object transform.local scale. During this interaction, we toggle the animator's scaling parameter, ensuring the character smoothly transitions into a zoom in or zoom out pose. For projection, we configure the AR camera to use perspective mode. We also manage shadows via a shadow controller script. By toggling scene light or shadows between soft and none and adjusting each object's shadow casting mode and receive shadows, user can enable or disable shadows on demand. A simple UI button updates its text dynamically to reflect the current state, providing an interactive way to control scene lighting. Finally, all of these transformations are tied together with Unity's animator component. We use Boolean parameters isMoving, isRotating, and isScaling to drive transitions between idle, jogging, rotating, and scaling animations. This approach ensures that every visual change is accompanied by a smooth, context-appropriate animations. That's all for our ACG techniques part. Thank you.
Assalamualaikum and hi, my name is DALILI and I will be explaining the UI setup in Unity for our AR project. Our AR app uses multiple canvases to manage different user interface screens. And these canvases are controlled through an app object in the scene called App Manager. First, let's talk about the App Manager. In the inspector, you can see that it has several scripts attached. The Quit app handler handles the quit process. So when a user wants to exit, it activates the Quit app panel. The Help panel controller activates the Help panel when the Help button is pressed. The Ground Plane Manager is responsible for detecting flat surfaces and placing our 3D model Hutao. And lastly is the shadow controller, lets user to toggle shadows on or off using a button. Now let's look at the canvases we use in the hierarchy. First, in the in-app panel, this is the main gameplay UI. It includes the joystick for moving Hutao and buttons like reset and toggle shadow. These elements are always visible during interaction. In the inspector, this canvas is set to screen space overlay, meaning it stays on top of everything on the screen including the camera feed. Next is the help panel. When users tap the help icon, this panel appears to guide them with instructions on how to use the AR app. It's hidden by default and only shows when the help panel controller activates it. Lastly, we have the quit app panel. This panel shows up when a user wants to quit the app, giving them options to confirm or cancel. Like the others, it's a canvas with buttons and is activated by the quit app handler script in App Manager. All these canvases are structured similarly using the Unity's canvas scaler, and graphic raycaster components, which allow UI elements to work properly on different screen sizes and respond to user input. That's a quick overview of how the UI in Unity is organized and controlled in our project. Thank you.
Assalamualaikum Doctor. So here I will be my name is HAIKAL and I will be presenting the UI for our project. So there's a disable shadow reset and the question marks button is a guide, a help guide. So AR object placement. So first user need to scan the environment, and when it detects a flat plane surface, it will show the square indication that when you tap the screen, it will place a 3D model of Hutao. So you can also adjust the position by positioning the square indicator around the flat plane, and then you just tap it. So there's an enable and disable shadow, and there's a button to reset the position of 3D model if the model is moved too far away from the screen. User can click the reset button and it will reset to its original position. So that is my presentation for our group project. Thank you very much. Assalamualaikum.
Good afternoon, sir. My name is Gankiyu. The part that I present is to demonstrate the rotation, scaling, and translation of 3D model. And see, I move the joystick, the Hutao will perform the translation, and I press the reset button, it will back to the point that is spawned. And now the Hutao perform the scaling by using the two-hand pinch gesture. And you can see it become bigger and smaller. And I press the reset button, it will back to the side that is spawned. And this is the rotation with using the one-hand pinch gesture. And I scale it become bigger and perform the rotation again. That's all. Thank you.